Here's 9b, a represent a rectangle rotating around the vertical line x equals 2. We're going to use the washer method. So first we'll do the entire disk, and then we'll cut out the hole in the middle. So the entire disk, pi times the radius squared, minus the little disk, which is pi times the radius squared. So the radius, the big radius, is from the green line all the way to the edge, which is the blue curve. From the green line to the blue curve, the green line to minus the x value of the blue curve, which is y squared. And then for the inner radius, it's the green line to minus the x value of the red line. The x value 2 minus the x value of the red line. So 2 minus and the x value of the red line for the small radius for the inside disk is the square root of y plus 1. You can write that as a single integral. Anyway, we're getting about 11.5. And I was able to still use those values, B and D, that were in the registry to do this. Of course, the represented rectangle reminded us that this was an integral with respect to y. So these indices are y values of these points. The expressions are expressions of y. They represent actual x values as functions of y and the differential dy.